rearranging equations, including equations with squares. So quick reminder about solving equations. If I'm solving an equation, I want to find out what the pronumeral is. And so to solve this equation, x plus 2 equals 10, I need to do the reverse of what was done to my pronumeral on both sides until I've cancelled out enough to just have the pronumeral on one side and an answer on the other. Now this is called making x the subject. When I've got something that says x equals, and then numbers or letters, whatever it is, x is the subject of that equation. So I'm going to subtract 2 from both sides. That cancels out the plus 2, leaving me with x here. 10 minus 2 on this side, and of course that's 8. Now we do need to be able to solve equations when what was done to my my original number, was it was squared. So they had a number, x, they squared it, and they got 25. We need to be able to reverse what's done to when it's squared, and remember the reverse of squaring something is the square root. So to reverse this to get back to x, I take the square root of both sides. Square root of x squared is just x, and the square root of 25 is 5. Check our working. X squared is 25, 5 squared is 25, so x must be 5. So there's solving an equation if I've got a squared in it. We also need to be able to rearrange equations. For example, this one here is x plus y equals 10. I might prefer my equation to be x equals something. That is, change my equation so it has the subject as x. Same here. The subject here is y. I might prefer the subject to be x. And these actually look quite similar to these equations that I solved up here. We solve an equation or rearrange an equation in the same way. Solving equations is just getting x, or the letter that we want, as the subject on its own. Rearranging is just getting the letter that we want as the subject on its own. So to get x on its own, I've got to get rid of this plus y. So I subtract y from both sides, leaving me with x equals 10 minus y. I've rearranged that equation to be in terms of x, or x as the subject. Here, y equals x squared. I just want x on its own. Sometimes it's easier to get the x on the first side first, and we can always just swap sides. So that's the same as x squared equals y. And that looks pretty much like that. How did I get rid of the x squared and just to x? I took the square root of both sides, and x is the square root of y. So they might ask us to express in terms of x. They might ask you to make x the subject. There's a lot of different possibilities. 2x equals y. We want to get x on its own by reversing what was done to it. We had x, we multiplied by 2 and got y. So we divide by 2 on both sides to get back to x is y divided by 2. Here, I've got something under that. Sorry, just clearing up. Rearrange, sometimes called transposing each formula to make R the subject. So basically we've got to start with R, work out what was done to it, and reverse that. So this is the area formula for a circle, and we're actually going to rearrange it to have the radius formula if we knew the area. I've got R, it was squared, then multiplied by pi, and I got A. We know R got squared first because of order of operations, saying that powers happen first. So to reverse order of operations, to rearrange or solve this equation to find out what R is, it was R squared times pi. Reversing that, I'll have to divide by pi first. Divide by pi on both sides, cancels out the pi here, and now I've got a divided by pi is r squared. So I had r, I squared it, and I got this. To get rid of that squared, I've got to do the square root. Now that's the square root of everything on this side and the square root of everything on this side, so it's a big square root sign, a over pi. Now, once we've got it to there, remember, of course, we do want the subject on this side, so we can just flip. This can take a bit of practice, but it is about remembering that this is really solving an equation to find out what r is. It's just that r now has a little expression of its own. Here's another one. P squared equals r squared plus q squared. So we want to get r on its own. R was squared, then q squared was added, and we got p squared. We want r on that side, so you can switch it over anytime you like. You can always swap the sign, the equals, one side of the equation for the other. So we've got r on this side early now, instead of doing it at the end. Either is fine. They thought of a number, r, they squared it, and they added q squared and they got p squared. So we reverse adding q squared. We subtract q squared from both sides. So we subtracted it from here and it's gone, and we subtracted it from here. Now, r squared equals all of this. So to get rid of that squared, we reverse it, we square root. That gives us just r here, and the square root of this whole side. Takes some practice. It's worthwhile doing a few in the textbook. Now, of course, we can also have to substitute and then solve, which is really the same skill again. Here's the area formula for a trapezium. They've said substitute in all these things that we do know, A, and H, to find the value of the one thing we don't know, which is B. So we've got a formula. We substitute in everything we know, leaving everything in there. So little a is 5 plus b times 4. There's a couple of different ways we could tackle this, but we had a number, we added 5, we multiplied by half, and we multiplied by 4, and we got 12. Now, we could combine these if we wanted. It would make it a little bit easier. Just find half of 4 to start with. But we could also just do it step by step. Dividing by 4 on both sides to get rid of this times 4. 3 equals a half times 5 plus b. Now be very careful. This is times a half. The opposite is dividing by a half, and this is why it's pretty tricky, because we might need to check 3 divided by a half is 6. Dividing by a half is the same as multiplying by 2. 6 is 5 plus b. We can leave the brackets out now because we've done everything outside the brackets. They thought of a number, they added 5, they got 6. We're subtracting 5 from both sides. 1 is b, and we swap the sides. So that is pretty tricky, dealing with each of those at once and dealing with this times a half is the same as dividing by 2. So dividing by a half is the same as multiplying by 2. I know we can stop the video now if you're happy, because it was a long video. If we preferred, we could have said we can always rearrange when it's that times that times that. I could have multiplied these. I could have got half of 4 and said that this was 12 equals 2 times 5 plus b, which would have been easier to solve. Because then we divide by 2 on both sides and we get back to 6 equals 5 plus b, which was where we got to.